welcome to more inverse trig variations. For this example, let's go ahead and evaluate the indefinite integral, which is the integral of 2 over the square root of negative 4x squared plus 4x plus 3 dx. So note in this case, this does not currently take the form of any of our inverse trig integrals. This does not currently take the form of any of our inverse trig integrals. However, it is closest to our inverse sine integral. So we have integral of a number divided by the square root of a quadratic, which fits more or less the format that we use for our inverse sine integrals. So what we are going to do is we are going to try to force that square root into a format that fits our inverse sine integral. So we are going to force the integral into the inverse sine format, or at least we are going to try to do so. So we have integral of 2 over the square root of negative 4x squared plus 4x plus 3 dx. We would like that inside to be something 1 minus something squared. So we want that inside to be 1 minus something squared. And so the way that we can try to pull this off is to go about completing the square. So we have negative 4x squared plus 4x plus 3. Let's go ahead and pull out that minus. So we want, since we want to minus something squared, I'm just going to do it from the 4x term, 4x squared and 4x. So we have a negative 4x squared minus 4x, both of those in parentheses, and then the plus 3 tagged on the end. So we have a negative 4x squared minus 4x, and then plus blank. Then we will have our plus 3, and we will then add on another blank. So in this case, to complete the square, remember the rule. If we have ax, sorry, that should have been a positive 4x squared inside my parentheses. We would have a negative, then parentheses, positive 4x squared minus 4x plus blank. Okay. Remember, if we have ax minus b, squared, that comes out as a squared x squared minus 2abx plus b squared. So in this scenario, we have a 4x squared minus 4x. So our a would have to be 2, since 2 squared is 4. Then we have negative 2 times 2 times b would be negative 4. So our b would have to be 1. So that means I need to give myself a little more room. I apologize. At this point, then we have negative 4x squared plus 4x plus 3 was equal to a negative 4x squared plus, sorry, now minus 4x, the negative, then parentheses, 4x squared minus 4x. We just figured out we needed plus 1. We still had our plus 3 originally, but now to balance out, this is negative 1. So to cancel out negative 1, we should add 1. So this is to cancel the negative 1 we added in. This becomes negative 2x minus 1 squared, right? That was the format for ax minus b. So 2x minus 1 squared plus 4. So at this point, we are looking at our integral of 2 over the square root of negative 4x squared plus 4x plus 3 dx is equal to the integral of 2 over the square root of, I'm going to reorder this as 4 minus 2x minus 1 squared, and then dx. Now, at this point, we can do a variety of things. Personally, I would prefer to use the original sine inverse integral format. So I'm going to force this inside into a 1 minus case. So if we pull out the 4, then this becomes the integral of 2 over this 2 over the square root of 4 times 1 minus 2x minus 1 squared divided by 4 dx, or the integral of 2 over square root of 4 is just 2. Left hand side, we have 1 minus 2x minus 1 over 2, whole thing in parentheses, squared, then dx. Giving myself even more room. We are now looking at the integral of 1 over the square root of 1 minus 2x minus 1 over 2, whole thing squared, dx. Now, if we go ahead and set u to be 2x minus 1 over 2, otherwise known as x minus a half, then we have the du is simply dx. And we are now looking at the integral of 1 over the square root of 1 minus u squared du. This integral we know. This was simply sine inverse of u plus c. If we plug back in, u equals x minus 1/2 or 2x minus 1/2. Then we wind up getting that our integral is equal to sine inverse of 2x minus 1/2 plus c. So completing the square enables us to kind of force different quadratics into a desired format for our inverse trig integrals. For another variation involving u substitution, let's do another example. Let's evaluate the indefinite integral, which is the integral of 3x over x to the 4th plus 16 dx. So again, let's go ahead and force that denominator into a familiar form. In this case, there's no square root. And so we'll try the 1 over something squared plus 1 format. In particular, we're going to aim for a u prime over u squared dx to get a 1 over u squared plus 1 du case. So we have integral of 3x over x to the 4th plus 16 dx. This is the same thing as the integral of 3x over x squared plus 4 squared dx. You have an option here. We can use our tan inverse case with the tan inverse x over a format, or we can go all the way. Let's go ahead and use the a format. So we'll just leave this at a equals 4. Let's go ahead and set u to be x squared. And we have du is 2x dx, or we do have an x dx involved. So x dx is 1/2 du. So plugging in, we get that our integral is equal to, we have a 3 over u squared plus 4 squared. Then x dx becomes times 1/2 du, otherwise known as 3/2 times the integral of 1 over u squared plus 4 squared du. Again, this is our tan inverse case with a equals 4. And so we wind up getting that this is 3/2 times 1/4 times tan inverse of u over 4 plus c. And if we plug back in the fact that u was equal to x squared, then we wind up getting that our integral is equal to 3/8 times tan inverse of x squared over 4 plus c. So these are some additional variations of our inverse trig integrals that we can use u substitution for. Again, completing the square is a common one. Recognizing higher powers can be written as something squared is also useful.